All right. Problem 6 of the practice final. We're just going to concentrate on part A right now. And we'll come back and we'll do B and C in a separate video. So for part A, we have this continuous time signal x of t, and it's a sinc function squared. Now we don't have a sinc function squared on our table, so we're actually I'm gonna go through the convolution with you because, and on the solution sheet, she just provides um, the triangle that it makes, but I want to go through how to get there because it's been a while since we did some convolution. So we have x of t is equal to sine 2 pi t all over pi t, and that's all squared. Or we could say x of t is equal to y of t squared, where y of t is equal to sine 2 pi t all over pi t. Now, that means that the Fourier transform, big X of j omega, is going to be equal to the Fourier transform of x of t, which is also equal to the Fourier transform of y of t times y of t. And we know that this is going to equal the convolution 1 over 2 pi from negative infinity to infinity of y of theta times y of omega minus theta. And I didn't write the j's in there, but the j's are, they're in there. I'll just leave them out for now. And we do this integral with respect to d theta. So this can be kind of tricky. That's why I just wanted to go through it. And let's just get rid of all this so that way we can kind of clean up. Now, the Fourier transform, big Y of j omega, is the sinc function. So if we look right here, we have 2 pi, and that's going to be equal to, what do they have it on the sheet as? So they call it W. So 2 pi is equal to big W, which means that the Fourier transform is going to look like 1 when the magnitude of omega is less than W, which is equal to 2 pi, and 0 when the magnitude of omega is greater than W, which is equal to 2 pi. And that's what we have right here. And I have the x here, but these should all be y's, I guess. This is a y. This is a y. It looks like an x. Y. Y. And y. So now we need to convolve this. And the tricky part is setting up the bounds of integration. So let's get this out of the way for now. We'll put that up here, kind of where it's in the way but out of the way. And this is what we're trying to accomplish, because we know that this is big X of j omega is going to equal this. So here's this right here on the top left graph. This is just a plot of y of j omega. And now what I've done here is I now have plotted y of j omega minus theta, where theta is the horizontal axis, and I took a snapshot at omega equals negative 4 pi. And on the next one, I have y of negative j theta with a snapshot at omega equals 0. And the last one, I have y of j omega minus theta with a snapshot at omega equals 4 pi. So we're going to have uh, 4 regions here. We'll have a region where on the we'll have a region of when omega is less than negative 4 pi, right? And when omega is less than negative 4 pi, we're not going to have any inner connection between our two boxes, right? So that means that x of j omega is going to equal 0 there. And then when our next one, so right here, when omega is equal to negative 4 pi, we can see the boxes are starting to intersect. So what we need to do is we need to integrate from this time. This will be the lower bound of integration, and you can see right here at omega equals 0 that this front end of this one is now meeting the front end of this one. So that's going to be one of our integrals. So our next region is going to be from negative 4 pi is less than omega, which is less than 0. So this integral here, or this part here, x of j omega for negative 4 pi less than omega less than 0 is going to be equal to 1 over 2 pi. And we're gonna integrate from, we want to go from negative 4 pi. And what we want to do is we don't want to integrate to 0 because we're trying to get a formula for if we're in between, if our omega is in between these two things, right? So if omega if omega was, let's say, negative pi, we might be right here. So then we really only have to, we're only worrying about where these line up right here and right here. So we need to integrate to omega. So we're going to be integrating to omega, and then each one of these is just a 1 because they both have magnitude. Everything here has magnitude 1, so we have 1 times 1 d theta, and what that gives us is, man, all over the place. That's be 1 over 2 pi, and it's omega minus a negative 4 pi, which is equal to, what's that? That's, we have omega over 2 pi plus 4 pi plus 2, right? So this is x of j omega for this region here. Now, our next region is going to be when we're going from here, from this one here to this one here. And we're going to be integrating the entire time. Well, we know, we can imagine this box. We can imagine this box sliding along here, right? So this is a, let me start here. So this is at omega is equal to 0, right? Well, then we have omega equal to 2 pi. And look, we still have half of our box overlapping. And then as we keep going forward in omega, right, we can see that what the bounds of our integration depend on where our backside is, and we know we're going over to 4 pi because that lines up down here at omega equals 4 pi. So we want to integrate from omega to 4 pi. So when 0 is less than omega, which is less than 4 pi, x of j omega is going to be equal to 1 over 2 pi. And we have omega on this side, and we have 4 pi right here. And it is just once again, it's 1 times 1 d theta, which gives us 1 over 2 pi, 4 pi minus omega, which is equal to 2 minus omega over 2 pi. And then after that, our every x of j omega becomes 0 again. So what we end up with is x of j omega is equal to, we have 0 when omega is less than negative 4 pi, and when omega is greater than 4 pi. And then we have omega divided by 2 pi plus 2 when negative 4 pi is less than omega and omega is less than 0. And then we have 2 minus, get tight, and then we have 2 minus omega over 2 pi when 0 is less than omega, which is less than 4 pi. And to verify that it is the same, let me pull up Desmos here. Verify it is the same. We had y equals, it was omega divided by, or x, I guess we can use, let's do omega. I guess it's not going to go in there. We'll just do w. W divided by 2 pi plus, it was 2, right? And this is for, what was this for? This is for negative 4 pi less than w less than 0. And we had y equals 2 minus omega divided by 2 pi. And this was for 0 less than omega less than 4 pi. And just to verify that it's all in, it meets what she had on the answer sheet. Let's just go -1 to 5, and we can see we go from 2 pi right here up to 2, and then back down to 4 pi over here. So that's the first part. That's the convolution. Now, I don't recommend doing that on an exam. I just figured we should do it for an example because it's been a while. But if you don't remember how to do the convolution with just the pictures, then you're gonna have to do it with the formula, which, as you can see, gets a little hairy, trying to figure out your bounds and everything like that. But I'll be back with parts B and C in the next video.